Hello everybody. A while ago I made this random access memory, or RAM, in Minecraft. It was pretty neat. It's just on the inside, just a bunch of redstone piston work, a bunch of things going on, calculations, figure it out. So you can just select an address, any address 1 to 14, and then write any value to it, 0 to 14. So I could select address 2 and wait a few seconds. Yep, alright, we're good to go for our next command. That's the status lights. I can write 4 to it. Wait for it to update. Yeah, so that's pretty cool. Yeah, just write any address. So, or write anything to any address, and I can even switch to a different address and write something else. Okay, yeah, okay. Then I could even switch back to the original address. I totally forgot if it was 1 or not. Oh god, I forgot which address it was. We're somewhere in here. Nothing. Yeah, I can't remember what address it was, but you can switch between any address, and you can read from it with this thing here, as well as the raw redstone output with power, comparators like that, and then you could write to it. And so yeah, that was done here. I basically, when you select an address, it will store the redstone signal that you put in and then kind of decode it here. So if you did a redstone signal of 1, it would figure out which of these cells here has corresponds to 1. Also, there's cells over here. So that's pretty cool. It's a nice small design, but it is pretty slow. Like, I can't believe I called it RAM. Like, it's just not as fast as actual RAM, of course. But anyway, I remade it, and it's a lot faster. And it is a little bit smaller, but the core of itself is a little bit smaller, but I just brought the wiring out. I like it to look a little bit bigger, but I definitely could make it smaller. But anyway, yeah, same concept. We can select a value here. So address select, I can just select, let's just say address 2. And there you go. 2. Like half the amount of time. So yeah, that's the address, and then this is the value that's reading from it. 0 to 15 as opposed to 0 to 14 over here. And it's insanely fast, but the thing is, you only have 8 addresses to select from instead of 14. So it's faster, but it's not as big, like most solid-state drives and hard drives in real life. Solid-state drives are faster, but a lot lower in capacity. But yeah, easy peasy. Select up to 8, then you can write anything to it. So I can write 2 to it. Give it a sec. LCD really likes to take a second to update. Or I can write 3. That's funny because the output, or sorry, that's output. The output actually is a little bit faster than the LCD. Yeah, so that's okay. It's ready to take a next command. So these lights above them, when it flashes, it means it's ready to take the next command. So I can hit it, and yeah, it was ready. So the second I took off of that light, it was ready to take a next command. So I can do, even though that the read and write, or the LCD and the read speeds aren't the fastest, it will keep up if you keep giving it commands here. And then yeah, basically you can also erase the selected value here. Yeah, easy. Yeah, so that allows you to have 1 through 15 and then 0 as well. So that's pretty neat. it's same concept with memory cells. I just figured out how to, basically the thing that was really making it slow was getting the redstone signals. So I have to preserve that that value. So I gave it, you saw that I gave it so when I give it this, so when I do write value, give it this, it's gonna give it, so right here, the power of 3. And as whenever that goes on further, it does degrade over time. So I need to make it so it doesn't degrade. This is like probably the most optimal way to keep a redstone signal going through, as well as keeping that power value. But the thing is, it's not fast if you have it in mass amounts. Yeah, this is what gets up the signal to the LCD display. And since there's so many, it's not that like it has to go through all these. Here, I'll even break this just to show you. It takes some time to get up, and like everything, yeah, when it has to travel across a brick, yeah, it just takes a sec. But I optimized it as much as I could, really. There's still definitely more I could do. Like maybe like instead of seeing the signal go all the way around, I could figure out to make it go under. I don't know, whatever. But one thing that this does have that this one doesn't is the ability to kind of code something into it, like set up a program to it. And this is the serial interpreter here. Basically, you can do anything here. So you can set a value, run a function for it, then you'll get the output and then the ready signal. So maybe I could, so here's a list of functions. There's 4 functions. There's selecting an address, writing a value, deleting a value, and reading it. So I'm just gonna take this book quick. Yeah. And I'm gonna read it here. Alright. Anyway, so basically, I'm gonna write a value here to this green value. So I'm gonna give it a value of 2. And then that's stored in it. That's stored in the memory right here. Then I need to run a function with it if I want to. So you can select an address that's value. So if I run this number 1 here, so if I put 1 into this function thing, it will take this value, which is 2, and will grab the address that's like 2. So it'll grab the second address. If you put 3 or 4 in here, it could grab 3 or 4. I just need to put 1, the power of 1 in here. And then otherwise I could write this value, so 2, to the selected address. So right now, like, selected address is like, God, I can't count. 7. And so if I were to, here, I'll actually do it. So this is 2 in here. Write value, I'm going to give this a power of 2. So now, give it a sec. It's updating here. There you go. And it writes 2 to the selected address. And then I can also tell it to give me an output here. So this will be the output. I don't know the best way to go about doing this without signals interfering. Let's just see here. So 4. Oh yeah, I'll also show off the rest here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's delete this value here. Yeah, so give it a sec. Yep, it's gone now. Let's just write something else to it. Let's just see here. Yeah, I hate having to do this manually, but I'll show you an applicable use for it. So let's just write like 4, 5, 6, 7 to it. So 7 is stored in that value, and now we can choose what to do. So we can either choose with the function here we can either choose the memory channel 7, or we can write 7 to the correct to the current memory cell, and that's what we'll do. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I hope that's 15. I didn't hear it click the first time. So yeah, let's write it. And then, give it a sec. Boom, there it is. Alright, you might have seen this one flashed. So, here, I'll just show you this so we can see it some more. So, whenever something is done, and whenever something's used with the serial, yeah, if anything were to be controlled with the serial interpreter, so I'll show you here. If anything were to finish, it will send a ready signal, just to let you know that it's ready for another command. And that will be useful right here. So basically, let me just hook this up right. This is kind of like a serial cable, and it's transferring all the code and information. All you need here. Oopsies. Okay. So I have this hooked up to my machine now. This will... let's just make sure we have everything hooked up right. Yep. This is basically you can use shulker boxes. A bunch of shulker boxes, so it will basically run parallel with each other. So every time you press this button or it gets a signal, it will drop one of these down, and it will drop them down all in order, and it will feed in all these commands. So right now, with these shulker boxes, I've written a program with shulker boxes in this RAM, this memory circuit thing here. And I haven't tried it yet, but it should. It will take all of the, let's see, current memory, and it will just like all 8, okay, I don't know how to say this, okay. So there's 8 channels of memory. On each one of those channels, starting 1 through 8, it will write the first 8 digits of pi to those things. So channel 1 will have 3, 2 will have 4, or sorry, shoot, 3, then 1, 4, 1, 5, 9, 2, 6, 5, whatever. Anyway, let's just see how this works. Yeah, easy. So I need to let it do it one more. So these are ready to go here, just the one. So yeah, this one. So it will select channel 1 and write 3 to it. Yep, 3. And we'll give it the next one here. And check 2. So I definitely messed up in the code somewhere. Unless something's wrong with my system. Oh, no! No. I wonder what happened. Okay. Or maybe it's just all a little bit behind. So 3, 1, next one should be 4 here. Maybe I just messed it up putting in the system programming. Three, 1, 1. Okay. I just want to see how this is. I'll show you how. Okay, 3. Okay, I guess it's slowly getting there. And we'll take a look at the end here. But basically it's downloading this as program to this crap. This is just insane. Yeah, 3, 1, 4, 1. And it should be 5, 9, 2, 6. Yeah, Let's give it a sec. But this is like networking, and yeah, this is networking. This is kind of like a full-fledged computer now I think about it, but I'm just gonna keep it as RAM here. But this is amazing. It's two computers talking to each other, and this is sending information to this. It's downloading to it. This is insane. Okay. So this is 9, 10, 11, 12, 13, 14, 15, yeah. Okay. Okay, I was right. I was wrong. Yeah, it's working. It's working perfect. Yeah, and we'll just see all this stuff. Yeah, everything's going down. And it's on its last piece of code here. So loaded everything in order. I'll show you how we can write a little program of our own. Yeah. Okay, are we done? Okay. Maybe. Okay. Alright, let's see how well it works when it's downloaded. Let's just make sure there's nothing else needing to go through. Yeah, we're good. Okay. This worked weirdly. Okay. Okay. So, okay, we're gonna read all these addresses in order. Starting at alright, we need to select address select. Alright, we're gonna select. Alright, 1 should be 3. Give it a sec. Yep, 3. Then 1. Next one should be 4. 4. Next one should be 1 again. 1. Okay. 5. 9. Should be like right up here. And it should be 2. And then it should be 6. Good. Would you look at that? It actually worked. I did not expect that to work. Alright, awesome. Wow, I'm actually, yeah, that is insane. So, okay, I'm gonna make a chest here. Can you put shulker boxes inside shulker boxes? Probably not. No, you can't. That would be insane. Okay, I'm gonna, well, this is insane. Yeah. Holy smokes. Yeah. Yeah, I'm actually... Oh, yeah. This is insane. I wanna... Okay. Yeah. So my next project here is gonna be, so this is actually kind of a start of a redstone computer. My next up, I'm gonna have it, you can add values together, subtracts. But that's all I'm gonna go. I'm not even gonna try multiplying or dividing. But dang, I did not expect that to work. So yeah, well, thank you guys for watching this. Insane.